Welcome, ladies and gentlemen, to another edition of Binary Life, a channel that teaches new developers how to code by solving algorithms so that you can see how the thinking process is done and then how the solutions come to life. Today, we're going to solve the binary tree search, not the binary search tree, not the BST. And let's try to read the exercise. So we are given a number and a tree. We are given two things, a number and a binary tree. Now return true if you see the number inside the tree. Return false if you don't see the number inside the tree. And this is the structure of a node. Basically, a node is made of a value, the left part, and the right part. Now I've already solved this because I will not approach this solution like the previous algorithms. I have already solved this one. We actually do the execution flow so that you can see how the algorithm works. So because algorithm is simple, it's just 3 lines, but it's not that easy to grasp when just viewing at it for the first time. So it's better we do the execution process so that you can understand recursion for those who are new to recursion and understand this algorithm better. Now this is an illustration of a binary tree we can see on the screen, starting from the very top 3, which is the root. That is the root. It's binary tree because we say binary meaning there's just 2 parts. So it's a binary tree because it's a tree with every node having 2 neighbors. And each neighbor can have 2 other neighbors. And the last neighbor here, like in the case of 12, right, the case of 12, its left part points to nil and its right part points to nil, points to emptiness if you want. So let's try to execute this algorithm. This is the function. We're given a function here, search, yeah, that takes 2 parameters. It has a number and a tree starting from the root. So let's execute it line after line, then we see how it works. So the first line here, it checks if the root is nil. That's if we have an emptiness at the level of this tree here. And for our case, no. If we have an emptiness, it means there's actually no tree. So we return false. That's basically true. So let's say we were executing this algorithm while searching for the number 11. So it starts at the root here, 3. It says, is the root empty? If that's the case, return false. For this case, it's not empty. It actually has a number and it has a left part, this blue circle, and it has a right part. So it's going to check, is the value of the root equal to our 11 for this case. Remember, we're searching 11. So this is our n here. So is this equal to 11? Yeah. Nope, it's equal to 3. It's not equal to 11. So what happens? It's going to run this algorithm again. The function recalls itself on the left part or the right part. Why the or? Because it says basically if you don't see it at the root level, go and search on the left side. If you see it, right, we are done. If you don't see it, go to the right side. Remember, the or expression is either one side is true. If the first part is true, it doesn't go to the second part of the or expression. That's how it works. If the first part is false, it goes to the second part. That is why we have this or. So if we search on the left part of this tree and we find it, it won't go to the right part. Except we don't find it, then it's going to recall the function and go to the right part, this red circle here. So for our case, we're searching for 11. N is 11. So it's going to recall this function, search on the right part here, this part here. And what's going to happen? The same thing. It's going to start again. And when it recalls, this becomes the new root, 11 here. And it's going to check, is this one equal to, remember the algorithm, the first line again. It restarts the execution. Remember that. Is the root equal to nil? No, this is not equal to nil. And then, is the value equal to 11? for our case here is equal to 11. So it's going to return true here, and we are done. It's going to quit. That is how this works. If we were searching for 1, let's say n was equal to 1. Let's come here. Let's say we were searching for 1, n is equal to 1. After it's done with the left side, it won't find it. It's going to come to the right side, and it's going to join, come here, and then it won't see 1 at this top 5 most level. It won't see 1 here. It's going to go to the left side of 5 here, and it's going to find 1 there. If not, it will still go back to this part here. So I think we can see how the algorithm works. We actually search at a certain level. If we don't see, we go to the whole left side. We repeat the whole algorithm there. If we find it, we are fine. If we don't find it, we go to the right side, and we keep repeating the recursion process until we find the number. Else, we're going to reach a point where the root is equal to nil. For example, let's say we were looking for 70, like n is 70. We can see from the diagram there is no 70. So it's going to finish on the left side and finish on the right side and switch left and right until it's going to switch left and right of this final node. Like this is an end node here. When we go to, it's going to switch to the left side, which points to nil, and it's going to end at the first instruction, like is the root equal to nil, return false. So it's going to return false everywhere here from all the grandchildren, and the final return of this function will be false because we haven't found anything on the whole tree. So that is how this algorithm works. It's simple, 3 lines, but it comes with some complexion in understanding, especially for beginners, with the concatenation in 1 line of using recursion here and logical or comparisons. So I hope this is clear, and see you in another challenge for another algorithm. And thanks for viewing, and please don't forget to subscribe so that you can get notified for future solutions.